Yes. Okay. So what we're on now is getting the application to work on Linux as well as Windows. So we got it working fine on Windows. Now we need to get it working on Linux. So the biggest issue we have here, I think the only real issue, apart from maybe some network by order stuff, is the socket. So in Windows we're using this Windows socket. Linux we use the POSIX socket. Now the thing is, these socket APIs are very similar. The way we do things in Windows is actually almost identical to the way we do things in Linux. So I've got a file here that I wrote a while back. This is just the basics of getting a TCP socket to work in Linux, and it looks almost identical to what we have in Windows. So what I'm going to do, just to make things simple here, is I'm going to write my own socket API that will kind of abstract away the OS specific socket instance, so I can just worry about sockets and not have to worry about whether I'm on Windows or Linux. It'll be its own API, and then Fenrir will use that. So that's what we're working on today: Linux and Windows sockets. We already have the Windows sockets. We need to implement the Linux, and we're going to do that by creating our own API. So the first thing we're going to do is actually go ahead and create this API. What am I going to name it? I think I'm going to call it, I'm tempted to just do a TCP socket, because I'm going to have it TCP specific, but I might just do socket or socket API. Let's go with, I might do TCP socket. I might do that because it is going to be, it'll be written for the way I use it, which is going to be IPv4 TCP. Nothing special there. Yeah. This isn't a big deal, but this is always the hardest thing, is naming something, isn't it? I think I think with the UDP socket, things have to be done a little bit differently anyway, so well, I mean, it's going to be a TCP implementation. It's always going to be IPv4. And for naming and stuff, having it called TCP socket will actually be a little bit nicer. We're going to go with TCP, and I can change that if I want to. So first, let's look at what we have in Fenrir here. Our socket, we have a socket ID, which is our own ID that we assign, and then this is the Windows specific. This is the Windows specific socket handle. This is agnostic. We already have a handshake. We have a buffer and then a buffer. This is a receive buffer. This is a send buffer for the socket. Yes. Okay. I'm gonna have my own struct, I think. Where does this socket get stored? So read line from buffer takes a socket. don't even remember what this is. Read line. Oh, right. Read like an HTTP line, I think. Yeah. So if we work with socket IDs, it doesn't matter which implementation we have, that's fine. Okay, well, let's start where we actually create the socket and whatnot. So let's go to this here. So we start off over here. On Windows, we have to do this stuff. We have to initialize WinSock, and then we have to do all this other stuff. So we'll have to do that in ours as well. We'll have to initialize this thing. Yeah, we might as well do this too. Okay. So let's grab this. This is the thing I'm not sure about. Get address info. Can we just kind of hide this away? It'd be nice to not have to deal with that. And that's the thing. I'm always going to be AFINet. I'm always going to be IPv4, maybe even IPv4 and IPv6. It's always going to be a sock stream because it's a TCP socket. Protocol, iProto TCP. Okay, and then AI passive. It's always going to be that way. And then we have to get the address info. The port you specify, well, you could create multiple sockets on different ports. So when we initialize, we don't want to do this. This is when we create the socket that we want to do this. Yeah. So I think we should, initialize WinSock. We're going to grab that. Then we're going to go to, I thought I had that in a buffer. Okay. Shit. Where is this TCP socket file? Yeah, okay. So why, oh, I haven't written anything in the buffer yet. Right. So we go to this WinSock file and we paste this. Right, so I can save it here. So, should I have this in a namespace? So this is TCP socket. I don't know if that namespace should be. I don't know if I should have everything in a namespace or not. Yeah, okay. TCP socket. And then in here, this is going to be init. Init TCP socket, which doesn't really make sense because I'm not initializing a TCP socket, but TCP socket, init TCP socket, and so we do this. There's gonna be, well, okay, we'll get to that after. So let's go back to Fenrir. Man, I wish it wouldn't. So we do that. Oh, did I grab the wrong thing? Yes, I did. So this isn't in there. So we're going to say init TCP socket, and then we're going to have a function create socket, And when we create a socket in Fenrir, do we have the socket ID? How do we get the socket? We have sockets, which is this map. So this should be yeah, this should be in the TCP socket, right? So the map we need, right? So we have sockets, it's socket ID to an actual, to a socket pointer, and then next socket ID static, and that's just indicating that it's not meant to be used outside. It's not meant to actually this should be internal as well. Alright, TCP sockets, we have this, we have this. Back to Fenrir. So I'm gonna copy this whole thing here. Yeah. So in a TCP socket, what do we do? What do we do? We have to do this. WSA startup, pick in the data, and then do we use WSA data again? No. We do that, and then if it's not 0, then there's something went wrong. Maybe we'll say fail to init TCP socket WSA startup. WSA startup error. So init TCP socket. And yeah, this could be a bool, so that we can say this doesn't work, then we print something wrong, and then otherwise it's true. Fail to init TCP socket. Maybe I could name it something else. I could name it like Windows Linux socket. WL socket, Windows Linux socket. So anyway, we initialize the WinSock. So we'll do that. We'll initialize it. Something goes wrong, returns false. We know it failed. Okay. Then we're going to want to create a socket. So we should always return a handle to the socket, right? We can return a pointer. I think that's okay. So socket. See, it should be socket or TCP socket. Create socket. This we could just say init TCP socket init TCP create, and it returns a socket. So we do this, right? Get address info. If the problem happens, we say WSA cleanup. Return null pointer. Get address info fail. Yeah, maybe I shouldn't do this then. WSA there, get address info fail. Otherwise, so we say socket. Boom. It's the listen socket. That's your socket. I'll just say sock. Socket, sock. If it's invalid socket, fail to create socket, and we get the error, we then free the address info. Right, it's a pointer, free the address info, and call WSA cleanup, and then return again, return null. Otherwise, if it's successful, then we just return okay. We actually have a socket here. But anyway, we have this, and then we have bind, right? Bind the socket, so we call bind. Now, yeah, I think we should take the socket ID. So bind, we need the actual socket to do this. So here's where we actually create a socket. Yeah. So we actually create a new socket. We set the socket ID to be whatever. Right. Right. So socket ID. If the socket ID is next socket ID. Right. Create our socket. Set the socket ID. Set the socket. Socket is sock. And then sockets, the socket ID is that, so then add it there. And what we would return is socket here. I think I'm gonna keep it as TCP. This is specifically a TCP socket. I'm not gonna be doing UDP. If so, I'll create a separate library for UDP socket. Maybe. Yeah, so bind, we do this. Then we need to do this. So if this next socket ID is maximum, then set it back to 1, go back to 1, otherwise increment it. And then we keep doing this while sockets find socket with the next socket ID. If it's not, if it exists, if it's already in there, then skip it, go to the next one. Right. So that's how we do that. Unique sockets. Bind, it takes a socket ID. So we would need to get the socket. I think we should have a function. Creates a socket. I think we should have a function. Get socket. And it takes a socket ID. Actually, no, we can, that can be, what do we do? Get a socket for that ID. If it's equal to that, then we have a problem, otherwise return. I believe it's a pointer. Yeah, it's a pointer. Return null. Another way we could do that. Is just say return if brackets so it's easier to read. If this is equal to that, then this, if that's the case, it doesn't exist, so return null. Otherwise, return second because we need socket, right? So that's that. So get socket. So here we can say socket. Get socket. So now we get our socket. If the socket is null, if we don't have a socket, then there's a problem. If the socket is null, then we have a problem. So we try to bind. If the socket's null, that socket doesn't exist. I'm not gonna have it print stuff though, because yeah, I don't think I'm gonna have it print stuff. Might do a thing where it shows the last error. Do something like that. USC startup error. let's just make sure this is all good. So namespace is TCP socket, so TCP socket, so create get socket bind. Yeah, I kind of want to say here create socket, and even bind, I would say bind socket. Bind the socket ID. If the socket doesn't exist, then find the socket, then so last error. Invalid socket ID. Invalid socket ID. So binding it, what do? We just bind the socket. This is socket. If there's a problem, then last error is equal to this. Failed to bind socket. Okay, here's the thing. We still need, we don't need the info. We need these two specific things. Address length and then the address. So we're not going to do this because so there's two ways I could do this. I could just have the whole thing on the socket, or I could just store that. Yeah, so there's two ways I could do this. I could socket might actually be TCP socket. Not sure. I'm not sure how I want to do with the namespace. If I want to do instead of buffer, this is going to be the read buffer. So there's a read buffer and then there's a write buffer. The whole handshake thing, that makes things a little bit more complicated. Yeah, that makes things a bit more complicated. Yeah. Well, this whole thing is going to be more complicated now because, wait a minute, no. On Fenrir, we're going to have our own sockets as well. Okay, for the Windows and Linux APIs, all we need is a socket ID, which is really just a handle. It's really just a handle. For Fenrir, I'm not sure how I'm going to change this now. Okay, well, we'll get to Fenrir after. So bind socket. Choose a socket ID. Yeah, we shouldn't have to deal with any socket stuff. So like, there shouldn't be any of, so this, we don't need that, we don't need that. And but we do need this. This would be socket, this would be TCP socket. Okay, the port. So when we say create a socket, we need to know which port. I don't get why we need to do this. I'm gonna have it that when you create the socket, you say which port you want it to bind on, and then when you bind it, it actually binds it. Because here when we create, we don't actually use that. We use the family, the socket type, and all that. We don't actually use the port until we get to here, I think, right? So when you bind the socket, yeah, you just bind it. You don't have to say anything. So when you create a socket, we need to know which port the socket will have, and that could just be an int. Right? It could be a short. I'm just gonna say, it doesn't matter. I'm just gonna say int, right? It's just gonna take an upward. If you do have an invalid port, that's your problem. Now, it's gonna take a string, but we actually have so port, two strings. I'm not sure if that's the right way to do that. Convert the into a string, and then we have that. We have this here. Now what we want to do is we want to store, create our TCP socket. That's our socket ID. This is the socket. Put it in there. And another thing we want to do is we're going to want to store this stuff here. AI address and address length. Now what is that exactly? What is that exactly? It takes a pointer to a socket address. Type def struct. Or actually more specifically, yeah, AI address. AI address length. AI address. Right, this information is, yeah, this makes it a little bit tricky. Create a socket in it. I'm thinking maybe we just combine the two. I'm gonna create the socket, then I'm gonna bind it. And again, this is only for the server, so receiving anything. I'm not going to have it set for client stuff. That could be added later. It's going to be used as a client socket. Curious what in .NET, for example. Yeah, if that all happens in the bind. So creation doesn't actually do anything. So maybe all of this should be in the bind method. And then if you want to create a socket for, but you just create a socket which does nothing. And create socket would return the socket ID, nothing else. So what we're doing here is really what we need to do if you're gonna bind it, right? We create it for this and then we bind it. Yeah, I think that's what I'm gonna do. So bind socket, you're gonna pass in a port. Bind socket, you pass in a port, and it will return socket ID. So bind socket, and we delete this. Don't need that. So bind a socket on a port. What do? Well, we do all this stuff. There's the port. We then create our socket. Right, then we create a TCP socket, set the ID, set the socket, set all that. We don't need this anymore. So that's all good. And then yeah, I think we do this. And now we don't need to do that anymore. Create our socket, set the next socket ID. I want to make sure I'm doing this right. So yeah, there's an error. Return null. Null. Right. Yeah, for the address info, return null. Do all this, and then we bind this socket with all this information. If there's an error, failed to bind socket, free the address info, and then we're going to close the socket, and then WSA cleanup, and then we return null. Otherwise, free the address info and then return the socket ID. Now we have a bound socket. Right? listen. Socket ID. I might just go back to just calling it fine. So get socket. I don't think we should ever even look at this socket stuff. We should never care about that. I don't think we're ever going to care about that. So I'm just going to say get socket. Static, so it's not intended to be used elsewhere. Okay, so listen. Listen's pretty simple. What do we do? Listen. We need the socket. So socket, socket, get socket. So get the socket. If the socket is null, then there's a problem. False. Invalid socket ID. Invalid socket ID. Listen. Is socket. So listen. Socket error. I'll just say failed to listen, and that the last error is that, and then we close the socket. We don't have to say WSA cleanup though. Right, last error failed to listen, close that socket, and then return false. Otherwise we're good to go, so return true. Listen. Bind. Listen. Then we have accept. So accepts a connection. We're going to get rid of this while loop. So we accept a accept. Same thing again. Socket. Socket ID. Otherwise we say accept. Accept, that gives us a new socket. It states client socket. So yes, this stuff we're not going to do. check if the client socket's invalid, then failed to accept. Brief pause. Brief pause. Okay. Failed to accept socket connection. Failed to accept socket connection. And then we see, why do we need to do it? If we accept and it fails, I don't think we need to close the listening socket. I think we just don't do anything. If we accept it and it fails, it fails. If we accept it and everything is good, then I think I'm thinking about this the wrong way. I don't think I need this socket object. I don't think I need to do. All I need is the handles, right? Even when we're gonna be sending information, you're gonna pass in the buffer anyway. I think I'm thinking about this completely wrong. There is no TCP socket. In fact, I think we should just have, so here we have socket ID defined as an uint32t. I don't think we should do this. In Fenrir, I'm still gonna create my sockets, but using a different interface. So, yeah, well, I'm trying to create an API to kind of go one layer above the Windows and the Linux API. That's all I'm doing. It's a minimal layer above the two. So, what I want to do is I really want to say like type def. Outside of the namespace, because yeah, so type def, so socket in this case would be socket ID. So when I say socket ID for Windows, it means socket, right? And then this, we don't need any of this. Don't need this, don't need this. That's all going to be done. Fenrir is doing that, right? This isn't going to do any of that. So we do that. Get socket, we don't need to do that. Find the port, returns a socket ID. Again, we just do that. Instead, what you could do here is have this as a boolean, and then socket ID, socket ID. And so we do this, socket ID, and so we say socket ID, set it to null. Right, and then here we just return false. We don't need to do this. I was making it more involved than it needs to be. I'm not creating like a whole wrapper. It's just one layer above, just so I can go between Linux and Windows without have to change it without having to change anything. So here's the thing: if I try to create a socket and it fails to create a socket, I shouldn't just. The whole thing doesn't have to shut down, does it? We definitely have to do this, but do we have to shut the whole thing down? I don't think we have to necessarily shut the whole thing down. If we try to bind and it doesn't work, we have to shut this down. Right? False. But if everything works, then we return true. And the socket ID is socket ID. Right? Socket ID is sock. Right? That's how we do it. So bind the port and then the socket. It's going to be output. Listen takes in a socket ID. It's actually listen socket ID. Whether it works or not. Accept takes a socket ID. Yeah. It's kind of a wrapper to them. I have a bind method which does all that stuff. My bind creates and binds. So you have the client socket. Okay. Otherwise, you just return the client socket. Yeah, we just return the client socket. So that's accept. And then all of this, we don't need any of this. Right? 83 lines, it's not that much. So accept, and then I'm gonna have a method called free, which is like the opposite of init. So free will call WSA cleanup. So we have listen, accept, bind, and init, TCP socket. I might rename socket ID to TCP socket ID. Yeah, I might do that. Do I want to do that? Socket ID, TCP socket ID. If I have a UDP, it'll be for UDP sockets. So, yeah. Okay. And then free. Oh, so I may, okay, yeah, you also want to close the socket. Close TCP socket socket ID. Close socket. Okay, let's go back to Fenrir. So that's all of this. There's also this. Windows, we include this socket. Let's go to Fenrir. So here, let's say include TCP socket. Right, TCP socket. And everything's going to be the same, but instead of a socket here, it's going to be a TCP socket ID. That's going to be my socket there. TCP socket ID. So let's actually do that replacement. So this is going to look completely different now. When we say listen, we do that. Initialize WinSock. Instead, it's going to be TCP socket init. So TCP socket init, and that's okay. That's all this. All that, and then you say create socket and then bind it. This can all be done in one thing. So instead of socket, this is a TCP socket ID. Instead of okay, let's actually okay, what we can do here is TCP socket ID is TCP socket. There you go. Yeah. And then we can also say instead of socket ID, because it's not a socket ID, sock or socket. And the reason is because we actually have, it's actually a socket method, right? Yeah. Yes. Okay. Fenrir. Up here and create our socket. Instead we have a TCP socket. It's the same thing as we did before. So we initialize. So now we say listen socket. Instead of saying socket, all this stuff, what we say is TCP socket bind the port, which is server description.port, and actually listen socket's going to be here. Socket, and then is it, what's a string? This the TCP socket last error return false. So then we don't have to then bind it. And we don't have to do all this stuff. Bind socket, so init. Right. Init. So init. Socket bind the port, listen socket, where is that defined? So TCP socket, listen socket, so remember socket. Now we have to listen, so this is going to be TCP socket listen socket, and that's it. TCP socket listen, the listen socket. If there's a problem, failed to listen, and it should be an S. I still don't know. So this just makes things a lot simpler. So now we just initialize, bind the socket, which creates a, so bind creates and binds, listen, and start listening. Oh, right, we do need to say TCP socket free, right? If we're gonna just terminate. Otherwise, you come in, accept connection. So this is instead a TCP socket, client socket, and it's TCP socket accept the listen socket, and that's it. So just accept. No, this should be the same client socket if TCP socket client socket accept. Wait, accept is a blocking call. If it's invalid, that's down here, right? We return false, but we also say we have to say TCP socket free. So clean things up. And we also want to say TCP socket close the listen socket. Close that socket, free, and then we have an error. Failed to accept socket connection. Again, I still don't know if that's what the correct thing to do is there. TCP socket, what's the last error? So that's that. So if accept fails, we just do this. If accept succeeds, we don't need to check this stuff. And we do what we normally do. Okay. Yeah, I don't think there's anything different there. Just gonna go back here to accept. Right, TCP socket client sock. Right, so we return true. TCP client socket, client socket. Right. What socket is that? Okay. All right, let's go to include TCP socket. Let's take a look at TCP socket. There are some errors, not many. It's just this here. Oh, this should be TCP socket. Yeah, this should be TCP socket. Okay, and then client sock. Okay. Back to Fenrir. Oh, we got rid of the the type def. Why does it have to be an int? Let's just say int socket ID. This is a TCP socket. So what we would say here as well is include this, and then we would say using TCP socket. Using namespace TCP socket. I'll still be explicit here just so that it's clear. Okay. But up until this point, this looks okay, right? Initialize, find the socket, listen, and then accept the connection, TCP socket, accept. Okay, everything's working here. Now let's get to actually sending and receiving data. So this is what we actually call it on the socket. Okay, so instead here, we're going to be saying TCP socket, TCP socket send, and then it's the socket and all this data. So we're going to need the socket, we're going to need the data as a string. The data as a string. Actually, no, I should keep that generic. It could just be any kind of data. And I'm not gonna have an argument for that one. I'm just gonna leave that. Use that argument, so I'm gonna put that there. And then we just say send, and if probably should have kept all this before I changed it. Okay. So accept, close, free. So, we say send, it's just the socket, right? And then the data, and the size, if it's with the socket there, then del to write response. I'm surprised that worked. I thought that was valid. S. Okay. So send. I might just call it write. I don't know. In .NET, what do they call it? Send. I'll keep it as send. So what does the Windows 1 take? It takes const char pointer and a length as an int. The question is, what does the Linux one take, right? Linux one is this write method, and so it's a size t, and then it's buffer. It's just an array, const void. I think that's okay. It's bytes, right? At the end of the day, it's bytes. So yeah, at the end of the day, it's bytes. So const char, const char pointer, buffer, and I'm just gonna have an int buffer length, buffer size, or maybe just len, buffer len. Here's the buffer, and then the buffer length. Right? Yeah. Send, and then there's receiving. let's go back to the send method. TCP send the socket, the data, all this. Instead, we don't have to check this now. So send, if there's an error, failed to write response. Oh, I think I fucked that up at a lot of places. Yes, I did. I didn't need to. Yeah. I think I screwed that up. Oh, maybe not. Okay, is there another send? Yeah, TCP socket send. It's the same thing, but this, we don't need to pass this in. If not, if not, right? If it's false, is a problem. And then this changes. This is a string, and then this is. Error. Okay. And then the other one is this guy here, send data. So it's a TCP socket. Send buffer. Don't need to send that stuff. And same thing here. Yes. That's it. Those are the sends. And I think there's receive. There's only one. So on the socket thread, we receive. So this line needs to be right here. So send int receive TCP socket. So no. So sock receive. We need a buffer, which is going to be length is an int, and then it's just a char pointer. Okay, so just do char pointer buffer, and then buffer length. That's it. Receive. So the buffer length, and then we say 0, and then we have the number of bytes. I think this is just the same. Let's return that, right? Okay. TCP socket receive the socket buffer, the buffer size. And then I don't need, those are flags. I don't need flags. So Select is this number of bytes. What's our error here? Say send. Oh, I think there's flags. Yeah. So we have that. And then here we have an error. Let's go back to main. Namespace here. Yeah. Wait, why was that a problem? Right, okay. Okay, let's see if this compiles. What happened? So initialize. Oh. But right off the bat, ported 8472. What's the error? Failed to bind socket. Some bunch of garbage. There is no S print F string. Yeah, he's thinking the same thing I am here. Plus 23 has a print method. Finally, we've finally gotten to that. 2023. Wow. One thing that I kind of do need here is TCP socket. Yeah, I was include string, right? That doesn't have any effect on this, does it? It has to be a C string. It has to be a C string. Of course it does. Of course it does. So in here, inside of Fenrir, we have to see last error. What did I just hit there? I don't even know how I did this. So we're failing in the bind method. We don't know why. There's just no message. It's empty. Oh. If bind failed, if listen fails, right? Except fails. Boom. Yep. Sends us data, we send it right back. Okay. So that's phase one. That's the Windows socket. That's the Windows socket. Now we need to do the Linux stuff. So the Linux stuff, I could either have the whole thing, either Windows or Linux, or I might be able to replace certain things with other things. So first is determining if it's Linux or Windows. I think what we should do is we should check if it's Windows, and if it's not Windows, assume it's Linux. Win32 or underscore Win32 or Jesus Christ, why is there that many? Underscore Win32, you're in Windows. I'm gonna try that, underscore Win32. And let's see what that does. Yep. We're in Win32 because if I go here, I say include hey. Doesn't include it because it's not there. Okay, so that seems to work. Win32 is defined. That's a symbol. Okay. So now let's get started on the okay. So Win32, we include that, we include that. Now, if it's Linux, we're gonna need this. Type socket, this and this. So Windows we do this, Linux we do this. 113 lines of code, that's not bad. That's kind of just a small, simple wrapper. Win32 or Linux. Okay. And then Linux. Do we need to initialize anything? We don't need to initialize anything. So that's their first example. First example, init. If it's Windows, we do this. If it's Linux, we do nothing. So I could have the whole thing include all these preprocessor checks, or I could just have the whole thing wrapped in one big preprocessor check. I'm still not sure what I'm gonna do. It depends how much stuff is different, and a lot of stuff isn't different. So yeah. Okay, well, let's skip this for now. Let's look at the complicated one. All these other methods are pretty simple. Let's look at the complex one. Bind. So a port and the socket. So this stuff we're doing here in Windows, I think it's the same in Linux. It's actually identical, right? Right, family AFI net, sock type sock stream, protocol. Here we set the protocol to iProto TCP. Here we set it to 0. I bet iProto TCP is 0. It's 6. Okay. So that's different, and then flags passive. So the only difference here is the AI protocol. Okay. The only difference is the protocol. And here we have get address info, null pointer. It's going to be that this is the same hints info. It's actually identical, and on Linux, if it's not 0, then it's an error as well, I believe. Get address info. Return 0 if it succeeds, otherwise it's an error, right? So anything that's not 0. So it's identical. Alright, so the only thing really now is the protocol. So Linux, that should be 0. Otherwise it's good. All these WSA cleanup things. Instead of WSA cleanup, let's just say free. Right, when you free, what do you have to do? You don't have to free anything for. So this should actually be free. We'll just say free, and that's going to be determined by the version. This is all the same, except for Linux it's 0, Windows it's this iProto TCP. This is the same. Actually, let's get this into a side-by-side. I do that. Right. There's a bar on the left that I need to change my vim script file to not have that. Okay, this guy here. Do I still see? Yes. Okay, so this guy here, can I open? Nice. Okay. So right. Yes. Then we call socket. It's the same thing. Info AI family sock type. It's the same thing. this is the same thing. For Linux, the socket is going to be different, right? So here's another example. So if we're doing Windows 32, then we have this. Else we do type def int. Int. TCP socket is just int. Right. So it's either this or it's this. Let's get back down here. Right, there's all these things now. Invalid socket, bind. Here's the socket, AI address info, and then AI address length, socket error. -1. Yeah. Right, okay, so all these things are different. It's going to be a bit messier, but I think I'm going to have the defines all over the place because that way I can just kind of keep the structure the same, right? I think that's what I'm going to do. So define 32. Right, so if it's a Win32, then we do this. Otherwise, just don't even do that. Bind, we do this. Whoa. Weird. Else, it's going to be hints AI protocol 0. Right, Windows, Linux. This should be identical. Now we get to socket. That's identical. Negative valid socket is actually -1. Now invalid socket is 0. So if sock equals 1, right? So if it's Windows, we're checking this. If it's Linux, we're checking this. Either way. How come I wasn't freeing the address info yet? That's actually just an oversight. It's the same for the bind. Else. So it's the same thing. Bind. Sock. I didn't static cast it. I don't think I have to static cast it. I'm just going to say it like this. Info AI. That's not the difference, but I'm just going to do it this way. It's not equal to 0. Right? I know this is how it is for Linux. That's what I'm going to do. Again, I didn't free the address info on error. And then, so free address info. Close socket. Oh, I didn't look at how to close a socket in. Oh, it's closed. It's not closed socket. Okay, that's good to know. So this should just be close. So, and in the free, in the cleanup here, if it's Win32, if it's on Win32, don't do anything, and then close. If it's Win32, I also say close and then the socket. Alright, set and receive are going to be different. Whoa, this is not what I meant to do. So this is just close and then a socket. I think it's not going to know which one I'm calling there. It should call the namespace one by default, I think. So where are we at here? We bind. Free address info is the same. So we'll just close the socket if there's an error. Oh, there's all these other things too. This thing here. So this should actually go up here, and then we can see last error. Failed to bind socket. And the reason is this is just printing a P error. We actually need the reason here. So that's the same here. Right. Create socket. So again, it's a bit of a mess, but it is what it is. I could separate them out into just two complete different things. I might still do that. Yeah, I might still do that. It's just these aren't huge differences, right? Like, these are small differences. So send and receive will be different. Yeah, they're not that big of a difference. So we call close and then we do this, and then when we get to listen, how do we listen on there? It's the same. It's listen, sock, and it's actually the same thing there. But again, we have to check. No. Listen, sock. Soma x connection equals 0. So we're checking for here. And then we get the error from that. If there's a problem, we don't say close socket, we say close. Call our method to close the socket. Right. That's listening. Now accepting. We call accept. Yeah. Socket, null, right? Same thing. Yes. Socket 1. That. Okay. Now sending and receiving data. It looks kind of bad, but it's not really that bad. sending and receiving data is here. So send, we take a socket here. I'm not passing in flag, so I can just say write. So Windows, no. So here we're gonna say write the socket, the buffer, and then the buffer length, right? And then if that's equal to -1, then there's an error. Right. Ignore that error. So filter rate response. Actually, this whole thing is going to be replaced by something else. Yeah. Here, the last error. Actually, yeah, this whole thing is actually. That's the last error, right? And fail to this. I have to figure that out. But all of these. We're already going to say failed to create socket, so we don't actually need to do that. We can just say what the error is. So these, I'll have to fill these in. Okay, so that's writing data, and then receiving data. So I'm still not sure at this point if it was worth it to do this. This is receiving, so reading data. Yeah, we just say read the socket, the buffer, and then the buffer length. Okay. I'm going to close this one. 157 lines of code, that's not bad. Let's come here and take a look. I have to fill in the error messages still. Do we say close socket? We do. Multiple places. Close socket. Yeah. Actually, it should be cheated there. Use the arrow keys. TCP socket close. WSA. Yeah, instead of this, it should be TCP socket free. Right, that's what it should be. Yeah. Span mirror looks okay. So we're on Windows. So we have this. Oh, this is. What was this? If send equals socket error, then there's an error sending information over. Do we have a failed to send socket data? Yeah. There is no error message though. If send doesn't work, I don't think there's an error message. WinSock 2. Yeah, WSA get last error message. Okay. We could say this is just WSA get last error. Get last error. Okay, so it should still work as normal because we're on Windows. Oh, yes, okay. Free is called by other things, and so is free and close are called by other things. So one easy way to do this would be just to, let's just cut these guys out, and then we have init. Yes. So close and then free. Where's the first place for the close is called? It's in the bind call, right? So we have close, free. There's the server. Boom. Yep. So we're good to go on Windows. Now we just need to have it work on Linux. So I need to test this out on Linux. This is going to be a pain in the ass because debugging is not going to be as easy, although the G++ compiler does give pretty good information. So that's the next step. Okay, brief pause. Okay, so what's left is to figure out how to get the error. So how do you get the error code? Error number is set to indicate the error. Error number of last error. Error no header file defines the integer variable error no. It is set by the system call. Okay. So I think I've got to include error no, and then error no is a what is this thing though? Is there a way to get the string value? Okay, let's see here. Oh, it is. Okay, str error. So you need error no, and then a string.h, which is different than string, I'm assuming. String.h. Are these the same? Okay. Period. Settle down. Okay, so I think I need error no and string.h. Let me just do this. str error, the error number. Let's test this out. So let's open up WSL. Now, so this should work already, right? On Linux, right? So G++, Linux, right? So that compiles now. Linux.exe. It's running, right? And if I try to connect to it, okay, so it's connecting. So now let's try forcing an error in here. So to do that, I think what I can do is one way to do it, I think, would be to set the port to be something insane. Like that. Okay, that doesn't fail. I can set a port to be something that's just off the wall. Maybe that's not the way to do it. To have it fail. Okay, let's do this. Let's set the protocol to be a protocol that doesn't exist. Like, let's say the protocol is 4. I'm not sure if that's actually an invalid protocol, but yeah, there you go. So that, but that just causes that to fail. It doesn't help us out here. So let's do that. There you go. Protocol not supported, but that's with a P error, right? That's with a P error. What if we don't do that? So let's try str error no. Should be I'm just gonna do right. str error not there, so we need to include this. See, it's not complaining about str error not being there. Protocol not supported. Boom. I guess the error number is defined somewhere else. Maybe I don't actually need error no. Error no. See here they're doing printf with a string. Because this returns a C string, I think. Okay, so if we include string.h, that's all we need. str error. So if we go back up here, So last error here should be str error and then the error number. Str error. Hold on. Yeah. So str error. Okay. Last error. Last error. Oh. Here. I think that's it, right? Yeah, I think that's it. So we need to include string.h. And I think that's it. Last error. These are C strings. I think that will work. Okay, so we think we have this working here. So, let's try it now. If we try to include this, everything else should work, but there should be a problem with interpreting data because we still need to handle the endianness of Linux versus Windows. So let's go here and let's say okay, I can't scroll up or down. What's happening here? Why can't I scroll up or down? That's just the top. Okay, let's start here. So Fenrir line 44. Line 44. What's wrong with that? Oh shit, this is a major issue. Has incomplete, a pair has incomplete type. Fuck. That's the only error though, right? Okay, those other errors. Fenrir has socket error. Oh, okay, right. So we do this. Right, set the socket to be socket error. Okay. This is a bit of an issue. Yeah, instead of doing that, I think what we should do set it to be socket error. Right here we're checking if it's socket error. Okay, we set it to socket error. Instead, I think we should do something more explicit, where we say closed, and by default, it's not closed, right? And then if we go back to here, we check if socket closed. And we do this, right? And then here, instead of doing this, we say close is true. This worries me. This is a major issue. What I want to know... Okay, C++ 11. Yeah, how can I do... I want to do at least 17. Yeah, I want to do at least 17. Is that how we do that? C++ 17. C++ 17, so let's try that then. Hopefully this will get different results. C++ 17. It's kind of weird that this fine in a Windows compiler but not in another one. And then this is still C++, is that 11? This is Ubuntu, right? Okay, I'll have to look at that later. First, let's try to resolve the other issues. So, oh, get last error. It's in Fenrir. Missed that. Right there. So socket thread, this is the socket's thread itself. So number of bytes is equal to 0, then the client has closed the connection. Otherwise, an error occurred, and just say what the error is. So this should come back to being S. Instead of get last error, we can just say TCP socket. Yeah. If we go to the TCP socket, this is in receive. So, okay. Need to look up something here. Let me read. On error, -1 is returned, and error number set to indicate the error. So we can do that. Okay. So read on success, the number of bytes returned. 0 indicates end of file, or for the socket, I mean the connection was closed. I think we can still assume that. So I think we can still say bytes, number of bytes, number of bytes. So if the number of bytes is, if it's greater than or equal to 0, we don't care. If it's less than 0, return the number of bytes, right? But then if number of bytes is less than 0, then an error occurs. So we set the last error. So if define win32, so win32, then we say last error is WSA get last error. The last error is just str error number. So it doesn't go back there. Right? So if it's negative, then we set the last error to that, unless it's the number of bytes. Now we go back to Fenrir. So receive, if it's positive, good. If not, client close the connection, otherwise fails to receive. Okay, so that should be good. Now what? These are all warnings. We only have 2 errors. Oh, yeah, so for declaration of struct JSON element. It's kind of weird because that's kind of weird. That's annoying. I'm gonna have to change that just for Linux. Okay, what are the warnings? Null used in an arithmetic. If socket ID equals null. What's wrong with that? I could say if what I mean to say is if the socket ID is 0, but why is null a problem? Format expect argument of type char pointer, right? No, that's valid. So Fenrir 335. Yeah, I can just do string. Same thing here, right? String. Okay, we're getting better. 639. 639. Yep, same thing here. Okay, so this I'm gonna ignore because I'm allowed to. Why can't I say if well, because we're saying null, but really the socket ID is a handle. Technically, it's a number. The 0 is just nothing. But I'm gonna keep null. I'm gonna keep that there. So that warning is fine. I will say this: G++ actually has this compiler is good. Like the error messages and the information it gives you, the suggestions are way better than what Visual Studio gives you, at least out of the box. So what's the problem here? Socket ID was set to null, converting from non-pointer type, which is an int, from null. Okay, but yeah, I don't know. I could just set this to 0. Not a big deal. This is the real problem for declaration. I'm not sure how I'm going to do that, how I'm going to deal with this, because yeah, it's this here. So the JSON element, I could have these as pointers, but I don't really want to have to do that. Yeah, I don't really want to have to do that. I'm gonna keep the null. I use it as a handle, so yeah. So I'm gonna ignore those 2 warnings for now. So we just have 1 error then, has incomplete type. These are really good error messages. Like, I really like these error messages. This is a little bit nuts, but this is really good. For declaration of struct. See, note, for declaration of struct, vendor JSON element. What does that mean, that note? But let's take a look at that here. Worst case scenario, I make it a pointer, but then I'm gonna have to go in and free all that JSON data, which, I mean, let's think about this here. These elements could have a map with a bunch of stuff. Technically, I should have these as structs, because otherwise, yeah, technically I should have these as struct, as pointers to JSON elements. Otherwise, every time you're adding something into this vector, it's going to copy it over. And same with the map. Every time you copy over an element, it has to copy everything deep down. Whereas if it's just a pointer, it's a lot easier to deal with. Okay, I think I'm going to do this. So we're just going to pointers. Now that changes things because where do we start with the JSON stuff? Here, read, or here technically. So from JSON, takes the JSON element. Okay, so this has to change. So JSON element pointer, right? It's a pointer to JSON. And now this is just gone, right? So from JSON, the data, we return a pointer now to a JSON element. And we return this. We'll print invalid JSON data. I don't think I should print anything again. How many things do I print here? All right. I guess I do have to have printing. Right. Index is 0. Oh, okay. I'll just copy this. JSON. Yep. So it's a pointer now. Read object. So read object. Oh, this is the change. So I'll need to do this JSON element object is equal to JSON object JSON element, and then we pass JSON object in. Reference to it, JSON element, JSON array, JSON element, JSON array. This will still take this, so I'm gonna rename object to JSON object. And I'm also going to rename array with JSON array. I think I fucked that up. Read. Wait a minute. It used to be read object, now it's I can do another one. Read JSON, read JSON. By the way, I think these should be static. Just to indicate that this is not meant to be used outside of that. So we take a JSON, so a reference to JSON element, JSON object. So we can just reference that, right? And then this other thing is another JSON object. Instead of calling it object, we could object fields. Okay, so this has to be different now. So JSON element child or we'll just call it on. Is equal to JSON element, and then you say this is equal to that. Now it's equal to a pointer. Okay. JSON object fields name is equal to that, and then just pass that in. Reference to it. JSON array. Here, so if we put it in fields like that, if it's just a value, then we say JSON element JSON value is equal to JSON element, and then we say value is equal to that, and you put it in there. I think. Okay. I hope I didn't fuck anything up there. JSON array, right? Same thing here. JSON element. This is a JSON object. And then JSON array. Place back is JSON object. Dereference that. Read JSON object. Element. JSON array. Place back is JSON array. Dereference it. And then same thing here. JSON element, JSON value, JSON element, and place back this guy. Place back JSON value. We can just put that down, and then value value is that. Actually, I think yeah, I did that there. Okay, so that's that. Now from JSON, so everything changes now. It's a pointer. Actually, no, I think all this can stay the same. So element fields find the name. The value is iterative second. This is to be changed because this is a pointer. And then from JSON, element fields find. So we say from JSON passing a reference to that thing. Okay, same thing, go through the fields. Second elements is actually a pointer. It's an element, the pointer, and so we dereference that. I think this is correct. This would be inferior. That all looks good. There's only one error, a few errors. Oh, I have to change the method signature of what? Oh, this is JSON. JSON object. What's the problem? Yeah, what's the problem? Oh. So read.json object needs to return. Wait, no. Read.json. This doesn't return anything. This doesn't return anything. Just return JSON object. Return no. There you go. It returns a point, so now things change with the way we use it slightly. Send, this is going to receive. So, right, so JSON element. So now we don't do this. Now what we do is we can just say JSON element pointer root. Or we can say JSON, which is this. Don't have to do that. So, from JSON, the data. And that's it, right? So that's actually nice. So now from JSON, pass in the data, and then we have a JSON element, JSON, and then we can say this, but now we just have to be careful. It's a reference to that thing. You also check if it's null or not, if it's, I think that's right. Let's try, this should still run properly. We're getting the data correctly. This looks good. Okay, this looks good. Let's go back here. So those warnings are still the same. At least we got rid of all that. Sock was not declared in the scope. Oh, okay. We're getting into some other errors now. TCP socket. It's converted from, where's that? Line 53. Line 53. Oh, no, I'm in the wrong file. 53. Right. Null, which is 0. It's either an int or it's whatever that is, which is an unsigned int. Okay, so that's a warning, and I'm gonna ignore that. I'll ignore those. So we have errors though. Line 73, socket was not declared in the scope. Line 73. Yeah, it should be TCP socket, right? That fixed all those issues. These are just warnings that I don't really care about. So we should have, I'm just gonna remove the exe again. Okay. Recompile. So now we have main.exe. Segmentation fault. All right, so we compile the application. That all works fine. But now we have a segmentation fault. This is where it's going to get challenging. Debugging Linux is going to be challenging. I haven't done debugging in Linux for a long time. Segmentation fault. I would need to figure out how to use a debugger so I can step through the application, basically. Where could the segmentation fault happen, though? So let's go to main. The main application. If I don't do this, right, if I just comment this out, there's no segmentation fault. Okay, so we know that, well, we know that it's in here anyway, but it's in listen. So let's go to Fenrir, listen. Shouldn't be here. I'm just curious. Let's see. Printf. Hey. I'll try doing it this way, and if I can't, I'll have to figure out how to get the debugger working. Okay, so that works. Oh, segmentation fault. Segmentation fault. So bind, and if there's an error binding, okay, so it's in the bind method that we have a problem. TCP socket bind. A and then segmentation fault. Old school debugging here. Yeah. Okay. I think it might be this this thing here, get address info. So let's go here and see if it's that. A and then oh okay, it's further down. It's further down. Socket. Hopefully it's not a segmentation fault for that. Okay. Yeah. Is it that? So the segmentation fault is here. Oh, did I do it wrong? Is it actually in the listen method? Oh. No, I was in the wrong method. It's not the bind. Yeah, it's the listen. Right? Put that here. Yeah, it's the listen method. So, let's just do this. That a segmentation fault. Okay. So is it? Oh, hey. Then we get a segmentation fault. Oh. Is it? It's not the close method, is it? Damn, it is. Oh, it's recursively calling itself, right? Close, this is closed socket. This, we need to be explicit. Okay, failed to listen, success. Fail to listen. If it's false, you say fail to listen, and then the last error is success. Okay, I think there's some things going on in here. So if socket error, or if this last error close return false, otherwise we return true. All right, okay, we failed to listen. For some reason this is saying success. So the error is just success. Okay, let's just for now, let's try something. I can't do that. Wait a minute. Is it because I'm interpreting this wrong? If listen is -1, then it's an error. That's why. If it's -1, not if it's 0. Okay. This is promising. Damn. Connected to server. We got this message back, which is correct. Okay. Bytes received 474, which is the handshake on socket 1. Client connected 1. We received 170 bytes. This is the message. Damn, okay, let's see if we can have multiple connections. I'm just gonna move this over here for a second. There is a, okay, so it's working on Linux like it is in Windows. The socket stuff seemed to be working well. The threading stuff might not be, because the threading stuff should be okay for any operating system. Yeah, this is for anything. All we're doing is including TCP socket now. Okay, let's, oh, it just didn't update this for some reason. So on Windows, it still works. I can connect. So multiple connections. This is sweet. This thing is sweet. Okay. So TCP socket. Oh, failed to bind address already in use. Yeah, we might run into that right now. Yeah, I think it thinks it's in use, but it's not. Because how come this guy can get it if the address is... it might be because it's the same process. I don't know exactly. Okay. We're pretty much there. So this code now runs on Windows and Linux. Yeah. Okay, now that works. I think the Windows just not updating. But it updates that. Oh, now it's working. Okay. Now I can disconnect. Client disconnected. Damn. That works. I think if I try running it, yeah, it doesn't actually kill the process properly. But then if I recompile, yeah, it still doesn't. And if I try running here, no. That works. Okay. Okay, so it's working on Windows, it's working on Linux. That's the TCP socket API. We're pretty much ready to start using this now as an actual server. Yeah, one thing I forgot now is when we're done, we're gonna need to free that memory. So, no. We're gonna need to free. So this here, so from JSON, we need to free this memory. So once we're done, we need to say free JSON, and then we pass in the pointer to the JSON, right? So this is gonna have to be in Fenrir, free JSON, and JSON down the pointer. So what do? We can say if JSON is null, then just don't do anything. Otherwise, Okay, so if it's got, we go through the array and we free all that. So for JSON element pointer e in JSON elements, you say free JSON and this element here. All right. So free that. Just a value, we don't do anything, and then we need to also do for auto key value pair JSON field. I think this is correct. The field has a name and then a JSON element, so we say free JSON kv.second. I think that's right. So free all that, and then once we're done, we free the actual JSON element. I think that's right. Okay, that looks good. Let's kill that. Recompile. Run it. Okay, good. We're on there. That looks good. That reconnects. Okay. Let me kill the server. Okay. I think that's it, right? So that's that. So next time, I think I'll work on when we kill the process, when we kill the application, it will shut down everything, free all the threads, and do all that, all the destruction. But that's it. Once that's done, that's it for Fenrir. We're ready to go. We're ready to use it. Yes.